Alright, so another problem with partial derivatives. We've got this thing. We want to find the partial of z with respect to x and the partial of z with respect to y. Alright, so let's go ahead and get started. So we've got the partial of z with respect to x. Okay, now remember, we're taking the partial of z with respect to x, so y is treated as a constant. Okay, treat y just like it's a number. All right, so let's look at this term here. Well, we've got e to the x and we have cosine xy. Well, that's the product rule. I've got e to the x times cosine. Okay, they both have an x in them, so they're treated like variables. Okay, remember the x is a variable, y is a constant. All right, so let's do the product rule on this term. So right now, I'm taking the derivative of this thing. So the derivative of e to the x is e to the x. So usually what I do is I do the derivative of the first term times the second term plus the derivative of the second term times the first term. Okay, so the derivative of the first term, e to the x, times the second term plus the derivative of the second term. Well, what's the derivative of cosine? Negative sine xy times the derivative of what you're taking the cosine of. So what's the derivative of xy? Well, what's the derivative of 7x? 7. What's the derivative of 10x? 10. What's the derivative of x times y, or yx if you want to look at it like that? It's just y. Remember, y is treated as a number. Okay. All right, and then that's times the first function. So this is the derivative of the second function, this cosine xy, and then times the first function. Plus, okay, and now I have to take the derivative of this. Well, this tangent y, it's a constant term. It has no x in it. So I'm taking the derivative of this. So what's the derivative of e to the negative 2x? Well, that's e to the negative 2x times the derivative of the exponent. So the derivative of the exponent is negative 2. And then I have tangent y. Okay. See, taking the derivative of this, that would just be like if we had this. Okay. This 5 here, that's like that. It's the same thing. So this would be what? 5e to the negative 2x times the derivative of this, which is negative 2, which is just negative 10e to the negative 2x. And that's what I did here. Okay, this is a constant. All right. So now let's clean it up some. So this is going to be e to the x cosine x y minus, I'm going to put all this in front here, so I guess we can put e to the x y sine xy minus 2e to the negative 2x tangent y. And this would be your derivative. Okay. All right, so let's go ahead and take the partial of z with respect to y now. All right, I'm going to pause the video while I erase this, and so I'll have some room up there. All right, so I'm back. All right, so now let's do the partial of z with respect to y. All right, so this time y is our variable, x is considered a constant. Okay, so let's look at this. So I need to take the derivative of this term. Well, look, there's no product rule for this part because e to the x is a constant. E to the x is treated like a number. So we're just taking the derivative of cosine xy. Okay, so I've got e to the x and derivative of cosine xy. Well, derivative of cosine is negative sine xy times the derivative of what we're taking the cosine of. Well, what's the derivative of xy? Well, it's just x. Remember, x is a number, y is our variable. This would be like, what's the derivative of 5y? It would be 5. Okay, all right. And then plus, now this, I'm not taking the derivative of this, e to the negative 2x is a constant. So that's e to the negative 2x. And then now we'll take the derivative of tangent. Well, because see, y is our variable. What's the derivative of tangent? Well, that's secant squared y. Okay, and so this is your answer. I guess we can do this. Negative x e to the x sine xy plus e to the negative 2x secant squared y. And this would be your final answer. Alright, so hope this video helped. I think I'll post another one. You can check it out. Check out the first two. I've got two other videos. The first one has examples 1 and 2. The second video has example 3, and then of course this one's example 4, and then I'll have an example 5 you can if you need to watch it. Alright, so thanks for watching. Don't forget to like and subscribe. Check out my other videos.